So today also I am going to continue the construction of the DFA. Till now I have discussed about the substring, ends with, and starts with. Now I am going to discuss about the construction of the finite automata over an alphabet sigma equal to a comma b, in which the length of the string is divisible by 2. Okay, so what is the string you are taking that should be divisible by 2? So that means the length of the string, if you perform the modulus operation with 2, you have to get the result as a 0 here. Okay, so normally if you have the sigma equal to a comma b, what is the language, what is that you are going to get in the sigma star? Sigma star is nothing but the clean closure of that particular language here. So that will be epsilon, a, b, ba, all these related to AB. What are the strings we are having related to AB? We will get that particular string. Okay. So what is the language we need is it should be divisible by 2. What is the string you are taking? That should be divisible by 2. We are not mentioning that the number of A's should be equal to the number of B's, or the number of B's is equal to the number of A's, or any other condition is not there here. It should be divisible by 2. So the language is epsilon, AA, AB, BA, BB, AA. So all this is the language here. So then what is the step 1 in this is as sigma. Here how many number of states are there? We don't know, because we don't know the length of the string here. We are not sticking to that particular string, that is suppose substring should be 10, or the ends with 10, or starts with 010. Like that, we are not giving a particular string here. What is the string you are taking? That should be divisible by 2. Okay, so that means in this particular condition, if the question is given like this, what we have to do is, as sigma is the minimum state, so sorry, so here epsilon will be there. Epsilon. Okay. So here epsilon, that means number of zeros are 0, number of A's also 0. So 0 modulus 2 is equal to 0 here. Okay. So here we are going to consider the epsilon also. In the previous cases, ends with, starts with, in that cases we are not going to consider the epsilon here. Whereas in this case, we are going to consider the epsilon as the minimum string. So if epsilon is the minimum state, so initial state and the final state should be same. That is, we will take it as a Q0. Initial state and the final state should be same. So we are going to take it as a Q0 here. Okay. Then what we are going to do? What is the read value for Q0? We are going to calculate. Is that any input we are going to give here? No. So that will be epsilon. Is that output you are going to give, any expected value you are going to give here? No. So that will be also epsilon. Okay. So the read value is epsilon and the expected value is also epsilon, because we are not giving any input here. It is a null string. Then we have to calculate Q0 on A is going to where? So by giving an input as A, we are going to check here. So what is the read value for A? Epsilon. Epsilon on A is going to where? We don't know. Epsilon A is there. But what we need? Epsilon A is there. Single A is there. But what we need? We need A or B. Okay. What we need? We need A or B. Okay. So here A or B we need, but we are not having any state like that, or we are not having any expected value like that. No. So what we have expected value is here A or B. So that like Like that any state is there? No. So for that condition, we have to take it as a new state. That will be Q1. Okay. So Q naught on B is going to where? We don't know. So what is the read value for Q naught? Epsilon on B is going to where? We don't know. Epsilon B is there. But what we need? We need A or B. A or B, not both. A or B as an expected value. So as an expected value, A or B is there anywhere? No. So we have to take a new state. We have to take a new state here. So that will be Q1. So for this reason, what we have done? We have created a new state here. So I have created a new state here that will be Q1 by giving the input as A comma B. Either you can take A or you can take B. So again, we have new state as Q1 here. We have new state as Q1 here. Okay, what is the read value for Q1? That will be A or B. What is the expected value for Q1? That will be A or B. Because if you read A, again you need an value to reach to the final state. Always you have to reach to the final state. Here final state will be Q naught. So again, if it is reading A, it has to reach to the final state again by reading A or B. So we have to give it as A or B here. So again, we have to check here. Q1 on A is going to where? We don't know. A. What is the read value for A? Sorry, what is the read value for Q1? It may be A or B. So you can take any value here. I am taking it as A. So A on A is going to where? We don't know. A is there. A is there. But what we need? A is there. So what is the question given here? It should be divisible by 2. So A is divisible by 2 or not? Yes. So epsilon is the value I need here. What is the epsilon? Where it is? In the expected Q naught. So it is connected to the Q naught from Q1 to Q naught by giving input as A. And Q1 on B is going to where? We don't know. What is the read value for Q1? B. B on B is going to where? We don't know. BB is there. But what we need? BB is there. So BB is satisfied here? Yes. What is the question I have given here? It should be divisible by 2. So it is satisfied. Okay. So we need nothing here. That is epsilon. So what is the expected value? Where it is found? Epsilon is found in Q naught. So connect Q1 to Q naught by giving the input as B. Now I am going to discuss divisible by 3. Now what I have discussed previously, divisible by 2. So but I am going to discuss divisible by 3 here. So what is the language we need? Epsilon, A, B, and so on, B, so and so on. Like this. That means I am not giving the condition here. That means any number of A's can be there, any number of B's can be there, but this should be divisible by 3. I am not taking any condition that only A's can be there, or only B's can be there, or this number of A's can be there, or this number of B's can be there. I am not taking any condition here. Okay. So if it is divisible by 3, then it should satisfy that condition. So here epsilon is the minimum string or not? Because if you take the input as a null string, so 0 modulus 0 equal to, sorry, 0 modulus 3 equal to 0 here. So it is that satisfying the condition or not here? Yes. So when the epsilon is the minimum string, we have to take the initial state as the final state. We have to take the initial state as the final state. So I have taken only one state, that is Q naught. It is the initial state and it is the final state. So now what I have to do? I have to calculate the read and expected. So what is the read value for epsilon? What is the read value for Q naught? Epsilon. What is the expected value for Q naught? Epsilon. So Q naught and A is going to where? We don't know. Epsilon. What is the read value for Q naught? Epsilon. On A is going to where? We don't know. Epsilon A is there. But how many A's I need again? 2 A's I need. How many B's I need? 2 B's I need. How many B and A I need? BA or AB I can have. So coming to the Q naught on B. Q naught on B is going to where? We don't know. Epsilon on B is going to where? We don't know. Epsilon B is there. But what we need? AA, BA, AB and BB is there. I need any of this particular string. Not all the strings, any of that particular string. So what I want here, I need a new state because this particular expected value is not there till now. So I have to go to the new state. That will be Q1. Okay. So here Q0 on A is going to Q1 by reading A comma B. But what is the expected value to reach to the final state? That is AA, BB, AB and BA. Okay. So again we have to calculate here. Q1 on A is going to where? So what is the read value for Q1? A or B? On A is going to where? A. If you take the, in place of A or B, if you take A and here AA is there. But again, what you need here? You need A or B. Because it should be divisible by 3. So you need A or B. Okay. So here A or B is the value I need. Anywhere it is found as expected? No. So what I have to do? I have to take a new state. So Q1 on B is going to where? We don't know. What is the read value for Q1? What is the read value for Q1? A by B. So what is the read value for Q1? A by B on B is going to where? We don't know. B is there. So if you take the B, in place of A or B, if I take B and BB is there. But what do I need? A or B, any value. So A or B, anywhere it is found as expected? No, I have to go to the new state. So that is Q2. So what is the read value for Q2? I can take A, I can read AA, I can read AB, BA and BB. Okay. So what is the expected value to reach to the final state? I can have A or B because if you take A, it will have AAA, ABA, BBA and BAA also. Okay. So here again I have to calculate for Q2 on A is going to where? Q2 on A is going to where? What is the read value for Q2? AA. On A is going to where? We don't know. So already we have found 3 A's here. Is this divisible by 2? Is this divisible by 3? Yes. So epsilon we need. Epsilon is there in the Q0. So connect from Q2 to Q0. And again, Q2 on B is going to where? We don't know. What is the read value for Q2? AB. AB on B is going to where? We don't know. ABB is there and it is going to epsilon. So it is epsilon is there in the Q0. So connect from Q2 to Q0. Okay. So now one more example I will take. The number of A's in the string is divisible by 2. So that means the number of A's, whatever the A's you are taking, that should be divisible by 2. It is not bothering about the number of B's. Any number of B's you can take. So in the language you will get the epsilon as a null string. So here I will take the initial state and the final state as Q0. And what I am going to do, what I am going to calculate the read and expected values for Q0. That will be epsilon. So calculate Q0 on A is going to where? We don't know. What is the read value for Q0? Epsilon. On A is going to where? We don't know. Epsilon A is there. But what I need? I need single A because 2 A's can be there. Or I need AB or BA. So is there any expected value like this? No, I'll go to the new state again. So here coming to Q naught on B is going to where? We don't know. Epsilon. Read value for Q naught is epsilon. On B is going to where? We don't know. B. Only B is there. But what I need, number of A's should be divisible by 2. But I am not mentioning about the B's here. So number of A's are 0. That should be divisible by 2 only, no? So that is epsilon we are going to take. So epsilon expected where it is found? In Q naught. Okay. So here Q naught connect from a Q naught and B is going to Q naught itself. And we are going to take a new state that is Q1 here. What is the read value for Q1? A. What is the expected value for Q1? A, AB or BA. Now what I have to do, I have to calculate for Q1. Q1 on A is going to where? We don't know. So what is the read value for Q1? A on A is going to where? We don't know. So epsilon, because A is there. A is divisible by 2 or not. The number of B's can be any, no? So that can be 0 also. So it is connected to Q naught. So from Q1 on A, giving an input as A, it is going to Q naught. And Q1 on B is going to where? We don't know. So where it is Q1 on B is going to where? We don't know here. So we are going to check now. What is the read value for Q1? What is the read value for Q1? AB is there. But what I need? Again, I need A because the number of A should be divisible by 2. Okay. So A is the expected value in Q1. So I am going to connect Q1 on B is going to Q1 itself. Okay. So that is construction of deterministic finite automata. Construction of deterministic finite automata with different examples I told you. So I told you substring starts with, ends with, and also I am taking divisible by 2, divisible by 3, number of A's is divisible by 2. All those concepts I have discussed in the particular session.